Assalamu alaikum and greetings. In this task we need to determine the inductivity between these two contours. What happens? Well, this conductor creates a magnetic field on this contour. Also, this contour creates a magnetic field on this conductor. So, there is some influence between these two, and the parameter that describes it, it is because of that we have inductivity between these two. This conductor has its own inductivity, this conductor here has its own inductivity, but also there's inductivity between these two. But inductivity between first and second and the first is the same and can be calculated as flux, which creates the first contour on the second divided with the current of the first conductor, or which second conductor creates on the first divided with the current of second conductor. And because we know that it is the same, we will choose the easier way. What will we calculate? So for example, here we know we have this problem. So the only problem which can be here is to calculate a flux. So how do we calculate a flux? Well, using formula BDS over surface S. That's the biggest problem. So we will choose what is easier, and we know to calculate. We already had tasks where we need to calculate a flux on this contour. So we will do that very easily. We had the same assignment. So we will calculate the flux which first conductor creates on second conductor. So this is on distance x, this is my infinitely small area, which means this is dx, this is height of my ds. We know that this infinitely small surface is base times the height, which is dx times the height. But as we can see, the height changes as we are moving with the x-axis. So which means that we need to determine and write the height as a variable of an x. So how do we do that? Well, using the similarity between triangles. So we have here small triangle, first triangle, this h. What is this side? Well, if this is a distance x, this I will get when I take h, subtract h, so this is x minus a. This is the height, so this angle is the same as here. This is beta, this is right angle, and now the bigger triangle. But now here the height is a, this is also a, this is alpha, beta, right triangle, and using the similarity between triangles I can use this two sides divide and it must be equal to this. So a divided with a is equal to this height divided with x minus a. So from here a height is x minus a. So ds is x minus a times dx. Our b is, we know, for infinitely long conductor, means 0I divided with 2 pi times the distance, but here we chose that the distance is an x. We write it as an x. So another thing we need to do is, this is integral b ds times cosine angle between b and ds. Because this is dot product of two vectors. What is angle between these two? Well, the direction of b is determined with the right hand rule, so we can see that it is from u to the table. The direction of ds, it is a normal to this area, to this surface, but it is because this is directed contour, we must use the same rule, right hand rule, curl our fingers in the direction of the current, and our thumb tells us what is the direction of n, and it has the same direction as b, it goes from u to the. So the angle here is 0, and we know that cosine of 0 is 1. So our flux V12 is equal integral b is me0 times x times our ds is x minus a times dx. What are the limits of our integral? Where we are looking at the x-axis, so where does my contour start? It starts from here, which is a, and it ends here, which is 2a. So, solving this integral, you will get that our flux is mu0 I1 to p a 1 minus natural logarithm 2 the unit vector. Inductivity between these two is V12 divided with its current. So we will actually get the same except this current. And the unit is Henry. And you have learned, maybe, that the inductivity does not depend from the currents, etc. It only depends from the geometry of the systems. So that's what we got here. As you can see, the inductivity between these two, we don't have anywhere a current. It only depends from the distance a, logarithmal, etc. It will depend what is the shape of this contour or this contour, what is the distance, etc. And we would get some constant values, other values, but we don't have a current. So the inductance does not depend from the current of these two conductors. Thank you for watching and see you in the next video.